Okay, so you've just had your solar system installed and you've chosen to go with a budget but still quality Sungrow inverter. This demo is going to show you how to jump online and use the Sungrow monitoring platform called iSolarCloud. It's just a basic overview of the platform for users that did not purchase this little add-on called the Energy Meter or the Smart Meter, the Sungrow extra add-on, which will show you how much power is going to the grid and how much of that solar power is going to your house. If you bought a smart meter, check out my next video and it'll go a little bit more in depth on the iSolarCloud monitoring platform. But for now, if you had a half decent installer install your solar system, they would have connected your inverter to your home Wi-Fi system on the day using your password. And then when they got back to the office, they would have registered an account for you. That's what we do. We send out the login details, which is the email address you provided with us and a password. So jump in there, put in your email address. If you can't find that email with your password, just click forgot my password and set up your own. We recommend you do that anyway, and log in. Now, if one of these installers installed your system,
10 o'clock, pub's open, let's go. Hi man, yeah, inverter's in the garage. That's the paperwork stuff. See you later, sucker.
Well, then you're going to have to connect your own inverter to Wi-Fi, but don't worry, you can follow this link up here and it will show you how to do that. And then you'll just have to go into iSolarCloud and click on that Register Now button and register an account for yourself. Now, assuming you've done that and you can now log into your system, you'll come up with a page that looks something like this. Now, if you've got a green tick and a circle around the image, that means your system is online. And if it's in the daytime, you'll see those arrows moving and all the figures showing. If that's not the case, then your inverter has lost the Wi-Fi connection to your modem or never had it in the first place. So you're going to have to reconnect that. And again, that's that same video to reconnect your Wi-Fi to your modem. Okay, now let's assume that you've got your Wi-Fi connected and you've got your account set up and you're logged in. The first thing you're going to look at is this little bubble chart here. And you can see at the moment it's just 12:30 on a winter's day here in Brisbane. And this 6 kilowatt of panels on a 5 kilowatt inverter is only producing about 3.3 kilowatts. You'll see later on that's because the panels are facing east and west, and in winter we're not expecting such high production on that system. And we lose a little bit in the inverter through efficiency, and it says here that all that power is going back to the grid. Well, that's not true, but because you haven't bought one of these energy meters, this smart meter, we can't measure the power that's going to the grid and the power that is going to your home. So as far as the system knows, it just says, all the power's going back to the grid. So again, if you did buy a consumption meter, look at my next video, which will explain all the features that you get with that smart meter, and your chart here will be just a little bit more full and more complicated. Okay, so we know our system is producing 3.35 kilowatt hours. It says it down below here. It tells you how much you've produced this month and the total yield, which probably isn't really that much interesting. This is the part that you're really going to want to look at down here, is the graph. And this is the power that has been produced so far today when you first look at it. If you zoom in here, you'll feel like you're gonna fall off your push bike or something. It goes all over the place. So just look at the graph, and if you click back an arrow, you can see yesterday's full day production. We had quite an overcast day here in Brisbane again, and you can keep on clicking back. The one annoying thing here is you can't go to a calendar, but I know that on the 25th of the 5th, we had a nice day of production. And you can see there that we've got a nice production curve. We've got no tree shading in the middle of the day on a clear day. We do have this little drop off at 4 o'clock in the afternoon, which is actually in this case from the building next door that is shading the panels later on in the winter. And we have the same thing in the morning here. So you might want to go out and see what is happening to your system at 10 past 7 in the morning, and why does it only turn on at 10 past 7, not earlier? Why do we have that peak? But the good thing you can see here on a clear day is we don't have some kind of tree shading in the middle hours of the day or anything. So that's the first thing you're going to want to look at. Now, if you go into total, and the reason I chose this system is we connected the system to Wi-Fi back in 2016, pretty much when online monitoring platform was getting really common. You can see we produced 3,000 megawatt hours for part of the year in 2016. But then for our full year of 2017, we did 8.4 megawatt hours. And then 2018, 8.2, and 2019, 8.5. Now, you'll want to know, is that system producing as it should? And again, if you had any decent kind of installer, the salesperson would have told you before they sold you the system what your system should be producing. And this is how we do it with a near map report. And this is that particular system here. And you can see it's an east-west installation. Panels are east and west. And we've put in there that it's 5.98 kilowatts of panels. We used Jinko back in the day, and we put in all the data there, and it basically spits out for us an estimate of what this system should produce. This system efficiency down there has got to do with dirt on the panels and cable losses and just real world conditions of what the system should be producing. And we can adjust that figure if there's shade or anything like that as well. Now, the energy output, 8.246 megawatt hours a year, is what we estimated way back in 2016. And in 2017, they did a little bit more than that, 8.4. We were just a little bit under that in our estimate, and 8.5. So you can see our estimate was fairly accurate and just a little bit on the conservative side. So the system is producing as we would expect it to. Okay, the other thing you can look at obviously there is that in 2017, we did 8.4. We dropped down to 8.2. If that now dropped down to 8 and then it dropped down to 7.8, you're having a fair bit of degradation every year, and you're kind of thinking, what's going on here with my panels, especially if it degrades a lot faster than that over the year. And that's at the point that you'd pick up the phone to us or your installer and say, what's going on here? Okay, so one other view that you're going to want to look at is year. And if you click back to year, this is what we've produced so far in 2020. And we can go back to 2019 and see the production. And again, as I mentioned, we produced a fair bit of power in January, and it's sort of around about half the amount of power in June and July months. And that is really because of this east-west orientation of your panels, but also every system is going to produce a significant reduced amount in the winter months. So is that system producing as we estimated that it would in each month? Well, again, you go back to the report that we gave you, and every installer really should give you a month-to-month report or an estimate of what your system is producing. And we estimated that this system would produce 28 kilowatt hours on average per day. Now, that's a daily figure. So if you get out your calculator and you go 31 days of January times 28 kilowatt hours, that's 868 kilowatt hours. And if you remember, this system actually did 941 kilowatt hours for the month of January. And again, we'll go back to June, and we estimated that that system would produce 15 kilowatt hours on an average day in June. So multiply that by the 30 days in June, and you'll get 450 kilowatt hours is what we estimated back in 2016. And in 2019, we produced 458 kilowatt hours. So we were pretty well spot on. 450 was the estimate, 458 was the actual. Okay, so if you look into that data a little bit more, you can go through month by month and you can compare how we went back in 2018 and 2017 month by month. And you can see here in October, we had a fairly bad month, and you can look into why, what was that, and we can compare that to all of our historical data. In fact, if we go into 2020 and we looked at the figures for January in 2020, we had a lot of rain in Brisbane in 2020, and so all of our figures for all of our systems were just a little bit under. So if you're not sure about how your system is producing, you can give us a call. We can compare it to other systems on our database from both Sungrow and all of our other systems. But there's one other thing that we can go in and look at for installers, and if you're that way inclined, you can look over here too on your left-hand side on Curve. So this is what we'd do if you called us up and you said that you thought your system was not producing properly. So if you go into Plant, you click on Inverter and click on that SG5K is your Sungrow 5 kilowatt inverter, and you'll see all of these figures come up. And we can then click on, say, the daily yield, the voltage, which is your grid voltage, A-phase voltage, the power in MPPT1 and MPPT2, or the voltage, which is the voltage on the east panels and the west panels. And we can find out all sorts of data, go in there and look whether our grid voltage is high. And at this point here, our grid voltage hit 251 volts, which is fairly high. If that gets over 253, the system will start limiting. And that's a problem with the utility. We would call up Energex in this situation if it got much higher than that, and ask them to reduce their grid voltage, to tap it down, and so that it stops our inverter from limiting the power. We can look at the voltage on the DC array, on MPPT1 and MPPT2, the east and west panels, and make sure that's working. And there's a whole heap of information that we can get in here from Curve. So Sungrow have really lifted their game in recent months and in the last 12 months, and there's a whole heap of information in here that you can get. Now, just to be fair and open, as I was shooting this video the first time, I got in here and I had all sorts of issues. And so there are sometimes glitches with any monitoring platform. So if you get that, just be patient, refresh, clear your cookies or something like that. And generally you can get the system working again, and or just wait for the updates from time to time that are continually happening with Sungrow. And I've just given them a heap of feedback today on some tweaks they can make with their system. Okay, so that's a basic overview of how you can check that your system is performing properly, and how we can look a little bit more deeper, or if you're the engineering kind of person or electrician, you can look a little bit deeper into how your system is performing yourself. I hope that's helped you, and if you can, give us a thumbs up on this video. And if you want some more content, we're pumping out a lot more YouTube content, so subscribe down below here and click the little bell so that you'll get alerts every time we put out new videos. Now, how have you gone with your Sungrow inverter, and how do you like the monitoring platform? Is Sungrow what we call in the industry cutter spec? Leave us a comment below and tell us what you think of the Sungrow inverter. Thanks for watching. Catch you next time.